Okay, good. As a session chair for the first session that we have this morning, I am expecting to introduce 7 people in 5 minutes, so I cannot go into details of the whole of all the speakers, but I will try to introduce a little bit in detail the elements that we have brought together. First of all, we have 3 presentations. The first presentation will be given by Karel Luyben. He's the Rector Magnificus Emeritus of Delft University of Technology until 2018, and he is now very active, I know, on the European Open Science Cloud, and that's precisely the topic where he will give a presentation dealing a lot with the data and mechanisms so that there can be cooperation, and somehow this should be making clear that we as engineers do not work in the cloud, but work with real systems and with real cooperations. But it's not easy and it's challenging. I will not say much more about his CV that you can find on the web. As a second speaker, we have Muriel Attanier. She's EARTO Secretary General since 2013, and EARTO stands for European Association of 350 Research and Technology Organizations. As Luc has explained, research and technology organizations are somewhere in between and are very constructive in the whole innovation process. Since she is representing these 350 research and technology organizations, she can give very good good practices and experiences and views on what is going on at that point, because the whole chain that we have from research to innovation and industrial implementation is a whole chain that needs to be taken care of. The third speaker that we have is Clarisse Angelier. She is Delegate General of ANRT, and ANRT stands for Association Nationale de la Recherche et de la Technologie de France. She is a professor also, and she will mainly discuss how the joint PhDs between the universities and the industry can be stimulated and can be encouraged and can produce very useful results, both for industry, also universities, and also for the candidates that really have good opportunities later on. Then we move to the panel discussion. The panel discussion will be moderated by Errol Gelenwe. He is a professor at the Institute of Theoretical and Applied Informatics, and he is a member of the Académie Royale Belge. Maybe it's worth mentioning here that he has been put forward in IEEE Spectrum, the IEEE journal, as the computer pioneers invention that made Zoom possible. So somehow he has recognitions that are really widely acknowledged and widely used. I will not say too much more about his CV, but we have then three panel members. Anna Fabianska, she's professor at Łódź University of Technology in Poland. She's working on image processing, and she is former, until 2021, she was a member of the Young Academy in Poland. We have made sure that for each of the 3 panels, there's always a Young Academy member that is present. So because we feel we need to bring in the input and the experience and the viewpoints of the young people in the game. Next, we have Saifu Rahman. He's a life IEEE fellow and the president of IEEE. as it was mentioned, to be the biggest technical professional organization dedicated to the advancing technology for the benefit of humanity. That's the whole world, but he is also a professor on electrical engineering, energy, and involved in the Power Engineering Society. And last but not least, he will, of course, be able to deal with the discussion on how IEEE is dealing with open access and the whole mechanism that is related to that, because IEEE is a very big publisher, as you all know. Then we have the third member of the panel is Michael Jutkevich. He is member of the Gas Technology Société of ARB and the former Secretary General of EIRMA, the European Industrial Research Management Association, which is regrouping 44 mainly large European companies. So the company aspect will be brought by his contributions. I will not dwell any longer. I will invite the first speaker, Professor Karel Ruiden, to give his presentation.
I was supposed to talk about the European Open Science Cloud, which, by the way, is not a cloud, but we will come to that. And Joost gave me the interesting title, The New Scene of Open Science and Scientific Cooperation in Europe, the role of the EOSC. I made it EOSC-A, EOSC Association, and the countries. So this is a challenging title, which I will try to deal with in 15 minutes. First, open science. The definition I will show to you is the definition we have accepted in the Netherlands, and we say it's towards more open access. It is towards fair data, and I will explain fair data in a minute, and towards embedding citizen science, or better, it's science as is towards science as will be. This will not happen automatically, and we saw this already in the previous speeches, and we need recognition and reward systems that change. If we keep on rewarding our scientists as we were, it will not work. We need support and training, knowledge of the researchers, but also support of the researchers in the form of data stewards. We need community engagement, especially if we want to come to scientific environment where we also involve citizen science, and we need infrastructures in order to do this. I'll mention that in a minute as well. And last but not least, which was also at the top of the triangle, policies. Usually the best way to do it is do it and then build the policies afterwards. We further need engagement, coordination, and support in order to go this route towards the future. This is not a short route. This is a decades-long route, which has started already decades ago and will continue for another couple of decades, especially with the data. My dream, let me start with that. My dream is as follows. If I plug into Google the Delft University of Technology, within a second, I get more than 35 million hits, of which the first one is the Delft University, understandably. Easy to find something about that university. If I look at Google Maps, where this Palace d'Académie is, it's easy as well. I plug in Palace d'Académie, and there it is. I can even find the route by pressing the route button to get here, either by train, by foot, or any other way. Wouldn't it be nice if I could find data as a researcher? I have been a researcher in the area of drying gelatin materials. So I put in data set on the drying of gelatin in Google, the same way as I did with the previous. And I get these interesting publications. The first one is in Nature, and all of a sudden it even is open access, so freely accessible. Open in open access does not mean open, it means free, but that's okay. It also has data sets with it, supplementary tables. And then if you look them up, you find this, a Word file. Unfortunately, difficult to transfer and no metadata with it at all. If you look in the publications, you find beautiful pictures showing the temperature dependence, the gelatin dependence. It is difficult to read. You have to have a lineal to read these data and then work with them. That's what I did when I was a young researcher. Wouldn't it be nice if we could get relevant data sets from other researchers in the same domain, as easy through a web of scientific data as we can find many things through an adequate search engine today? Why not? There's no technological reason why this is not possible. What are the requirements? The first requirement is that we speak the same language. And we don't speak the same languages, even not in the same disciplines sometimes, but definitely between the disciplines. And secondly, the results have to be findable. Well, somewhere on a internet connection through the web. The the results have to be accessible. You have to have access, not behind a paywall, otherwise you cannot use it. They have to be interoperable. That's a difficult one. If you cannot interact with those data sets and combine them with your own data sets, you're still lost. You don't have a lot you can gain from it. So the interoperability is the biggest hurdle in this list. And finally, therefore, we need standards for data. These standards will not for all data sets, for not all disciplines, no, within disciplines and within domains. So we go from these, then we come to the difference between open data and fair data. Open data is a, let's say, group of data you can find and you can use and reuse, and you don't need to reference it. It does not necessarily have to have the metadata with it, but okay, they're called open data. What we want is, of course, fair data, data that are findable, accessible, interoperable, and reusable. These 4 words have 15 principles under it. You can find them easily in the web, and the definition of them, Joost already showed them very quickly, a list of 15 principles. These principles are not standards. These principles are being developed as we speak and developed over time to make it easy to use them. But these are very important principles for the data and for the metadata. And I'll come to a few of the items in the course of this presentation. Of course, if the research is paid by public money, we want these 2 circles to overlap as much as possible. Not all data can be open for privacy reasons, medical data, for security reasons, or for other reasons. So there will always be data that's not open, but they still can be fair. There's no reason not to make the data as fair as possible. So the game is towards as fair as possible, depending on the standards as they are developed, and towards as open as possible. What is fair? Fair is not open. We could see it on the slide of Joost earlier on, as I just showed in the previous picture. Yes, fair data can be open, but open data is not necessarily fair. Fair ensures that it can be found, understood, and reused. And the most important thing is that this can be done by machines. So machines must be able automatically to find software. The data must know, based on what they find, what is possible to do with these data, and must know what they are allowed, this machine, this connection is allowed to do with this data. So it is machine actionable. That is essential in order to make this work. Simple, for the simple reason that we want not to transfer the data. We don't want to make a big cloud of data. We want to leave the data where they are, and we want to visit the data. This is the common thing in the future. Data sets are too large, too diverse, too dispersed. So you have to visit the data rather than collect the data. This is not a general rule. This is the tendency. And data can thus be shared under the restrictions of accessibility. Data can be accessible for some and not accessible for others, can be accessible not in the beginning, but accessible later on. So the time and the distribution is to be defined by the A of fair. Again, as open as possible and not as closed as necessary, because that sounds like it is open or closed. No, as restricted as necessary. It's probably a better term there. Ursula von der Leyen, 2 years ago in her Davos lecture, called this a web of scientific insight. And then she was talking of what we call the web of fair data, based, of course, on the internet infrastructure, the connections that are there, similar than the web of pages, the World Wide Web, but now data from the researchers and the related services. In the beginning, we have to offer some services, but gradually services will grow automatically, like all the services you can now find with the World Wide Web. 30 years ago, we did not start by creating all these services. These services came on the basis of the possibilities. You can now buy things, hire things, do all things on the web, which we could not predict 30 years ago. Same thing will happen here. It will be a federation of relevant, existing and future data sources. That's the intention we are creating. A virtual space where science producers and science consumers come together, open-ended with respect to the range of content, like the World Wide Web has no end, and the services you can offer on this content. Of course, starting from Europe, the European Open Science Cloud has to meet all the European data requirements, which sometimes is an issue in the discussion with the United States, with China, or with other countries. And it has to be in interaction with all these regions. It's no use making this for Europe, no use making it for a specific country. It's only useful for scientists if you make this for a worldwide system. To me, EOSC is a data infrastructure that could be seen as a twin sister or brother, if you want to, of the European e-infrastructures. The European e-infrastructures offer store, compute, and connect services. They can be used by EOSC to offer the servicing on data and the creation, especially of interoperability. So the combination forms a sort of yin-yang system. You have the e-infrastructures and you have the EOSC. And the both together is what we call the EOSC ecosystem. Data without e-infrastructures, useless. No computer, no connection, doesn't work. E-infrastructures without data, only zeros or ones, doesn't work either, no use. So the two are intimately linked in a yin-yang environment. What are the guiding principles? The overarching principle for developing EOSC is that we do this for the research. A lot of people say we do this for the researchers. I say no, we do this for the research, for the work the researchers do. And that helps, of course, the researchers. But the aim is not to do it for the individuals. The aim is to do it for the research process, to open that up for other researchers and for the rest of the world. Multi-stakeholder, if not all the stakeholders, the research performing, the research funding, the service providing organizations are working together, it's not going to work. Open, as I said, as open as possible, as restricted as necessary, and based on the FAIR principles. If we do not comply with the FAIR principles, it doesn't belong in EOSC. As simple as that, I would say. Then the Federation of Infrastructures is what we are trying to create. And as I said, it has to be machine actionable. Machine actionable, as I said, that the machine can find and understand it. What is the position of EOSC according to the European Commission? Well, according to the European Commission, EOSC, and these are pictures from the Commission, is a sort of tent data space underlying all the data spaces they are trying to create in the near future, mostly done in the health domain so far. So EOSC for them is the basis for science, research and innovation data space that will bring together the other resulting data space. All these areas have research and innovation activities, and that has to be part of the EOSC data space. What is the task of the association in this? The association we have set up, and of which I may be the president, is to develop and govern the federating core we are creating, to manage the authorization and authentication infrastructure, to manage the PID policies, the compliance framework, and the trusted certification. Doesn't mean that the association has to do that themselves. It has to see to it that this is done. We have to outreach to our stakeholders, monitor the services, and manage the trademarks, which we are heavily doing at the moment, and contribute to Horizon Europe policy. The partnership we have created is based on an MOU we have signed as an association with the European Commission. On the European Commission side for the European Union, this was signed by the two commissioners, Gabriel and Breton. And we have contact with DG RTD and DG Connect in this MOU partnership, Memorandum of Understanding, that forms the basis of the partnership. How do the countries come in? This is the contribution of the countries. They are coming in by an expert group of the Commission that forms a EOSC steering board. That's the title of this expert group, with which we interact and which is invited per definition to the partnership board in order to be in line with all the discussions we have on with the Commission on this. As I said, we have to do this on a global stage. So the service providers from third countries can already come in. They can, if they adhere to the rules of participation and if they adhere to the applicable legislation here in Europe. EOSC will work together with other regional initiatives. We frequently have contact with, let's say, the North America, South America, Australia, Canada, Asia, Japan recently, in the past also Russia, China. And that is where we built together with CoData, GoFair, Global Open Fair, the RDA and the World Data System, this worldwide system. What are the current challenges? Well, there are technical challenges. That is, first of all, the multidisciplinarity with respect to the interoperability. Interoperability within one discipline is not everywhere there, but it's relatively easy, but across the disciplines is extremely easy. For example, in the life sciences. Difficult, sorry, extremely difficult. It would be good if it would be extremely easy. For the short term, this means optimal authentication and authorization and a stepwise growing interoperability across a larger thing. The real challenges are social. So getting all the noses in the same direction of all the, let's say, stakeholders involved and seeing to it that we combine the local, regional, national, European levels in order to come to this open science commons. I deliberately call it the commons here, which it is, with the global convergence on standards. And we're trying to make first steps this year by issuing, or no, suggesting, not issuing because we don't issue, suggesting some standards. Okay, what I'll do is keep on dreaming. Come back to my dream in the beginning. If in 2040, 50% of the relevant research data, relevant, I mean relevant by seen by the researcher. And by data, I mean as well data, publications, and software would be as fair as possible, and as possible means as fair as possible at that moment in time, in 2040, when this is further developed, then my dream would become true. But we have to do this worldwide, so it's not as easy as it looks for Europe. Suppose this would happen, in other words, I would be able to find with a few clicks the diffusion coefficient of water as a function of temperature and as a function of the water concentration for different compositions of gelatin that I was interested in 30 years ago. I would be able to predict the drying behavior. At that time, drying took up 15% of the world energy consumption. How much progress could we have made with my computer program predicting the drying behavior in different machines if I would have all these data sets from all my colleagues? I didn't have them, and I had to do with measurements myself. This is hopefully thanks to EOSC in the future. Let's co-create EOSC, and thank you for your attention.
It was very interesting to hear you talking about EOSC. I have one of my old team members who's now in Technopolis trying to help the coordination of that one. And she's married to an IT guy, and that helps. Because I think one of the big challenges is all these commons between the different e-infrastructure that exist. And I think we have the challenges on the other side, the RTOs, to make sure that the data are fair. And surely some are restricted, as you know that very well. But even I think on the fair, we probably have some improvements to do for some of the data we have. So very, very interesting. I'm sure it will take some time. So I will look at 2040. We take the looking at of how things have advanced, and I think it will be interesting. So what I'm here to talk about, RTOs, I heard that in the introduction, you already heard the words RTO, so it stands for Research and Technology Organization. It's about applied research institutes. They are non-profits, they have a public mission, and their job is basically to scale up technologies. Their big job is to work for industry. They work as much for a large company than for SMEs. And they all have between a regional to a national angle, even if they many times work with clients worldwide. So RTO is a large association. We have 350 members. We cover most of the European countries. I would say those who have RTOs in Eastern Europe. Sometime we have Academy of Science, but not the RTOs yet. What I see is that actually Ministry of Economic Affairs in those countries are coming discussing with our networks, and especially with CEOs of the large institutes, to ask how to set that up. So I'm sure I have babies RTOs in the making in some of the countries. If I don't cover them now, I expect that it may take 10 to 15 years, but a few countries are coming up around. So what I wanted to present is a little bit the business model. So what are those ministries coming and ask, okay, I need to have an applied research facilities. How do I manage this? And I think the first things we tell them is that they have a special business model. We're not working like universities, not even as technical universities. Some of my members have actually been spin-off of technical universities. You know very well IMEC in Flanders. I don't have those in the Wallonian side, so I'm still hoping that Wallonia will come to us and asking for, advice on maybe how to set up similar type of organization. We have a small member in Mons, but not all the institutes are looking at us, and I think that's something we could look at further. So the business model of RTO is quite specific. We tend to show the Fraunhofer big model because they are the most famous. And we say it's 1/3 of public funds. This is the basic money they receive from their ministry. On this, they have to alleviate this with open calls, can be public, European, international. That's still public money. And then we are working to bring the 1/3 of industry. The reality of this 30% model is that these are the luxury RTOs, which have a lot of basic funding. What I see now is I have models in Sweden where it's more like 10% of basic funding and 80% funding from the industry, still working as an RTO, which means that the pressure to bring industry funds and working with industry and developing your technology infrastructure with industry is much higher. And they are the one to test a new business model for infrastructure with, for example, loans taken thanks to guarantee of use for 15 years of the lab by the large industry next to them. But that business model makes it quite particular for us to work, meaning that the link to industry is the priority of the RTOs often, to look at roadmaps where maybe the industry is not yet there and try to think 20 years beyond what the industry is being capable of thinking. Sometimes even thinking 5 years is very long. So when you are talking about investments in technology infrastructure, you're thinking 20 years, right? So we did a lot of work with the OECD to look at this business model and trying to see if it has evolved the last 10 years. So we have a new report, free and fair access to data of the OECD, so you can download. And open here means free, which is, I think, is good on that term. And what worked was they did a survey about 180 RTOs here worldwide, so also the Canadians, Australian, Japanese, etc. And I think they came up with what was striking all around the world was the use ministries, and not ministries of education and science, but ministries of economic affairs, were increasing the demand of support to industry for RTOs, but in terms of systemic approach. So not only supporting the automotive industry, for example, for cars, but thinking how do you support mobility in such ecosystem, and what will the car do, but what will also the energy system be, and the charging for the electric vehicle, etc. So that they were asked to provide a system view with the industrial component within. And I think that was an interesting conclusion of that OECD report. So I think also what came out the second pace was the fact that RTOs were playing, because of this systemic approach, more role of integrator, or let's say orchestrator of some ecosystem. Working with the university on one side, with the industry on the other side, with the regions, sometimes with the city, and trying to see what type of challenges there were in this ecosystem, both in terms of economic recovery, because we had a lot of examples of what was done during COVID, and also in terms of large investments that sometimes industry cannot make on technology platforms, which are becoming more and more expensive. So a good read. Something to say, we're of course doing tech development, and this is what I say, we have quite a market-oriented approach in general, so there's few examples to see also what we did, for example, on the key enabling technology, so not only looking at microelectronics, but also looking at their different applications, for example. We did also a lot of work showing also what we were doing with regions, and I think that's the conclusion I said came out also quite strongly from the OECD report. Even the very large national RTOs, and I have the example of the CIA in France, have been asked by the Ministry of Regional Development to open antennas in all the regions where they didn't have labs. And we see this is growing more and more as a request to support what we call the smart regional strategies, where here you have to have an innovation component. For not all the regions, this is automatic to think I would spend some of the structural funds on innovation. So the discussion was to push also regions with the structural funds to be a little bit more innovative in the spending, and not only on roads or airports or others, but to look at future labs, often in development also with the technical university, which is very often close to the RTO in the area. And I think this has grown. So we have now, even under the Horizon Europe program, a new pot of money given by the DG region just for those regional innovation ecosystems, where there the regions have the possibility to think in terms of future investments in technology infrastructure with the technical university and with the RTO in the area, and to get finance for feasibility studies and the pre-setting before the lab is constructed. So that's the 3I instruments that you have under the EIC actually at the moment. If I go back, that's not the plan. Something which all linked to what do we have, which is quite special in RTOs, of course, is the people we have in, but the most important is our technology infrastructure. And here what we see is that we have more and more issues with funding, not to start them up, that's generally not that complicated. The question is to maintain them and to keep them sharp, meaning that maybe you have a clean room, which I think I make, the total investments of the last 30 years was more than 2 billion euro. So we are now discussing with DG Connect, and they have different calls called the testing and experimenting facility. How are we going to put the next 2 billion euro in the next 50 years we need? And here you will have combinations of funds that are necessary. These clean rooms are becoming more and more complex. The prices are becoming higher and higher. So how are we going to keep up that those clean rooms are here and maybe not in Korea or in Japan or in the US? And here we need some investments. So ERTO has been quite active and is still quite active to try to develop a new program for financing of the technology infrastructure in Europe. And I think we have been developing quite a set of position papers on this with the rollout. What do we mean those tech infra are? So if you're interested to know more, and I think this program will be as much as for technical university as for RTOs. We see that often universities sometimes are richer, they can make reserve, and RTO has to spend the profit directly for the next year. So we can't make big reserves like some of the university are capable of doing. There is a lot of discussions on this also at European level. I think the other discussion we have is very much on skills, especially sometime how not to compete with industry and still provide some skills of the industry on the new tech. Well, we still also need to hire. I think that sometime what I see the pressure here is getting stronger, I think, especially those days. And I think that will be probably quite of a challenge in the future. To show you, when I say we're working with the industry, we see that also in the figure from the European program. We did some analysis of the last program, and we saw that, the average participation in this program for industry is 24%. And when we're looking at projects with RTOs, it goes up to 34%. So in general, we help bring the industry to the European program. So here you can see differentiation of this. And we, of course, have an event coming up. And if you see the topics we have on our events, and if I see what our CEOs are quite worried is, are they going to be able to keep the level of investments in their technology platforms to keep the age compared to, US, China, and other in Asia? That's one of the key issues. Are we going to be able to keep the level of skills? RTOs also provide professional trainings to industry on specific tech. So for example, I keep the example of IMEC in Flanders because we're in Belgium, they are hosting so many personnel from the industry in their clean room to test special components of their products. We need to still keep open while we still need to be restrictive. We are facing export control. We are developing tech, so we have regulation for that. We have a geopolitical environment which becomes tougher on tech. Russia is one, China is one, and then US on the other side. So the jobs of tech development, also discussion with industry starts to be more complex also to manage. So we have a lot of challenges, and this is what we'll be discussing on the 12th of October. So you're most welcome. And we give an award of innovation to our members every year. So we also give an award. And fair data is also an issue underlying many of the discussion. And the restricted part for us is quite key in certain environments. So that's it. I'm happy to answer questions later on during lunchtime.
Good morning. Thank you very much for your invitation to speak about the National Association for Research and Technology. I will go through my slide. ANRT has been set up for almost 70 years. We will celebrate its birthday next year. And as a reminder, it has been set up to boost to stimulate the relationship between academic world and business world. We gather most of the CAC 40 to the half of CAC 40, hundreds of small and medium-sized companies, and almost all the academic body in France. And that counts for 400 moral personalities that gather 10,000 people on all activity sectors and all scientific areas. And we built with them strong messages that we bring to the government, but also the Parliament of France. And they appreciate our messages because it's a cross-sectorial message and not the lobbying of just one thematics or one activity sector. Then we have some influence. And our aims that doesn't change for the whole life of ANRT is to inform our members on national and international matters. It's sort of benchmark. We allow them to exchange, to take from the other, to get some tips, to build for them, for example, or to answer or to apply for European codes, for example, or how to manage the research inside university or inside companies. And as I told, to influence to the government and parliament, and as I said, the power of collective intelligence. Then we work on some different topics. Firstly, to build message to policymakers on the management of the French research, how to organize the research in France to help the companies and academic body to work together. And for example, the autonomy of university matter, the IP matters, how to build, as Mr. Scheffner said, strong local ecosystems. And it's very important to bring together the mining of companies with the mining of academic body, but it's not so simple. And even 70 years after, we have again still to work on that. We work of energy matter. We are the member. We are member of the National Committee for the Strategy of Energy in research or through research, and it's very important to let industrial to speak together, to speak each other during meeting, a 1 month, a mensual meeting with the academic body, and set up some very manageable message for the policy maker. And I'm always very fascinated by the ability of industrial to speak together if we are just in the research and development matters, and if we not go to business matter, but in the framework of TRL 1 to 7 or 8, they are very key to speak together and exchange their point of view of this or other research matter. And it's very interesting for university, for academic body, for researcher, academic researcher, to listen how different companies want to see the point of views of for the future of this company. And I think we do a very nice job with modesty. Oh, sorry, I come back. And we work on the industrial, digital industrial policy, and especially about what we name platformization, the industrial platform and a digital platform in the B2B business. We know in Europe that we have lost B2C ability to set up big platform, but we think that Europe has a role to play in this context. And we work, and we would like to set up a big plan, national plan for manufacturing through digitalization. And as we name manufacturing with 4.0. And I think it's a very nice but very strong, very somewhat difficult challenge for France. And we contribute to emergence of the emergence of a new ecosystem. For example, for 2 years, we work on lunar space. And because we think that France, but Europe has to stand to be a leader in the race to the moon, because we know that China are already set up on the moon surface. We know how the Americans want to has always the lead, and we think it will be a mistake to be in the second way, and we push, and we are very proud because it's right now the International Astronomical Congress in France, and we are very happy to listen. And yesterday, our Prime Minister said that France put 9 billion on the table for that, for space matter, not only lunar space. And in about 4 years ago, I set up a new working group on pedagogy by gaming, because we think that I thought that it was very important to open INRT to the social and humanity science, but I think the France decrease in the ranking of PISA survey, and it's a very dangerous situation for our future generation. And I think that pedagogy has to be transformed, and the governments are very key that an association of INRT take the challenge. And we work also on the circular economy through the recycling, because I want to go through the concept with a bottom-up approach and a top-down. Then, now I would to speak on a SIF process to answer the commentator. And for most of 40 years, INRT was given a role to manage this PhD, industrial PhD funding program. And it's very interesting because this program put the PhD student at the heart of a public-private relationship. In fact, the doctoral student is employed by a company and is given a research mission at the doctoral level, but is advised, it is trained by a researcher in the framework of academic laboratory. And then the PhD student is sort of ambassador between his company and its laboratory. Is a PhD student enrolled in academic body, as all PhD students around the world, but he also worked for a company, and then he could place his research in the frameworks on the finality for the business. And as we saw about the TRL level, our PhD students work in the framework for 1, 2, 3 TRL, but it's important to see how they can link that to the future development and maybe to the future innovation, in not on a direct line, but it's important to not be just in the concept. And they have a good salary. First of all, we can see that this program increased by the time, and we are very proud to leave you to know that the government, the parliament, has decided to increase the funding of this program up to 50% by 2027. And we gather today 5,000 PhD students, and their previous courses are for half engineer school and for half master university, but sometimes they have both. And they have a very good salary because the average is more than 30,000 euros per year. Just to see or to show you that all scientific areas are possible in this type of program. And a very important thing is at the beginning, it was a big size company that lead this program, but now it is ECMIS that lead the program for 2 years. And it's very interesting to see how the small company are involved and are very keen to welcome a PhD student in their business affair. We have, there is a little deception about middle-sized company, but it's typical in France. France are built, as built is industrial organization with big size company and small, and there is no really numerous middle-sized companies. And all activity sector are involved in this process, in the PhD process. Well, a last word about what where they go, after the SIF process, what they do. In fact, they are 3/4 employed by the private sector, and it's very interesting to see that they are 1/3 to be employed in the company where they has done their SIF process, or go to another company, and just a 1/4 go or stay to the academic body. And I think it shows that the aim of the program is reached. Well, I think I have finished, and I conclude by scientific mindset, business mindset. Thank you very much.
Well, it's a great honor for me now to moderate this great panel. And in the panel, we are very fortunate to have different viewpoints being represented. And I start from my right and I'll move towards my left. On my right-hand side is Anna Fabianska. Anna is a professor at the University of Gdańsk in Poland. She is an expert in the field of computer vision. That's her field of activity. She was for 5 years a member of the Young Academy of Poland. And as you all know, the Young Academy is a fixed term, which doesn't stop her to come back in the quote unquote old academy later. On my left-hand side is Professor Saifu Rahman. We are extremely fortunate to have him here. He's the president of the IEEE, and the IEEE is the largest scientific organization in the world, the Institute of Electrical and Electronic Engineers. Scientific and engineering, of course, it's an engineering society primarily, but if you look at the fields of activity, although it's electrical electronic at the origin, it goes from engineering management to material science to photonics and so on. So it has a very broad spectrum of activity with different engineering societies inside different societies inside the IEEE. Professor Rahman himself is an expert on the smart grid. So energy distribution networks, energy generation distribution networks, this is his field of activity. At our extreme left, last but not least, is our very good friend, Michel Jutkiewicz, who's been for many years a member of the Belgian Royal Academy of Sciences, Letters, etc. The French-speaking version, let's say. although he's bilingual. He's perfectly bilingual, as are many people who are in the different academies. And Michel is an expert on management issues related to innovation and research. And he'll be able to provide us an insight into the different mechanisms that are available in Europe and whether they work well or not. So don't be surprised if he tells you things that are that to some may be unpopular. So we have organized ourselves so that we have 3 questions to launch the debate, 3 questions to the panelists to launch the debate. In the case of Anna, and the question was suggested by Jos actually, Anna, what exactly is open science and perhaps even open innovation to you? What does it bring? What does it add to your previous experiences?
Well, definitely, I would say that the open access and open science in general connects the researchers. It connects the researchers representing the less computerized, less digitalized disciplines with the engineers that could probably solve their problems, that could probably automate some tasks that they do on everyday basis. And it also connects the engineering researchers seeking for the data and seeking for the source code of some solutions proposed by the others. And this is exactly what happened to me, at least several times, when papers shared in the Green Open Access through the research social networks and papers accompanied with the source code of my solutions and the data just resulted in the very interesting collaboration and in the projects that I would never think of when starting them. And when mentioning this openness in general, the paper, especially in computer science, is not always sufficient to run the experiments. But everything that you need is the data and is the source code. So for these reasons, I totally agree with what has already been said, that together with encouraging the free access to the papers, we should encourage the free and open access to the data and to the source code of the solutions, or at least the software implementing these solutions and shared freeware and shared in the source open source format. Unfortunately, this kind of activity, I mean, accompanying the papers with these assets requires additional effort. So the benefits from these efforts are not always seen by the researchers. So far, this kind of activities strongly depend on the willingness of those who would like to put another effort in preparing the code, the source code, or sharing the source code, and put another effort for preparing the data. So I also agree with what was already said, that we need to perform a kind of work to change the mindset of the researchers, to let them see that this kind of activities are significant, are beneficial, and can be beneficial also to them, because it motivates, it boosts those collective intelligence when solutions are incorporated into the new solutions. And how it works, how well it works, I think that the example of this, how well it works, can be the recent rapid development of AI and in computer vision in general. Because those researchers from the computer vision, those who propose the most groundbreaking solutions, publish their papers in the preprint format, which are shared on the archive. This is the preprint repository hosted by the Cornell University. So these papers are readily accessible to the scientific community. These papers are also often accompanied by the data which become the very important for the other researchers just to benchmark themselves against their peers, just to benchmark themselves against the competitors, and also to provide the added value to the existing solutions. And the openness caused by those groundbreaking solutions are implemented in the form of the programming libraries which implement those methods. And these free programming libraries are used by millions of researchers and to develop new products, and are incorporated into many AI-based technologies that are already solved. So I think that my time is up right now, so I will forward the microphone.
Thank you, Anna. This was extremely, let's see, is it working? This was extremely clear and cogent, so well, that's a wonderful presentation. It so happens that on this panel, there are at least 3 members of the IEEE, 2 life fellows and a member. So don't be surprised that the IEEE president is here. Although we don't really operate as a mafia, there is a certain kind of interconnection in these things. And IEEE, just to give you an idea, has annual expenditures of about $500 million, $500 million roughly. So it's a huge organization. And I'd like Saifur to comment on what it does in the field of open access, with the understanding that IEEE doesn't do conferences and journals. It also does standards. And that's an important part of its activity.
Thank you, Errol. Thank you very much. Show the slide now or later? The slide later?
I think your slide should be up normally. Anna also had a slide, but yes, please do. But perhaps
let me start talking. Yeah. Good morning again. IEEE has over 400,000 members globally, about 30,000 in Europe and North Africa and Middle East. We have sections, one Benelux. TU Delft is a good place for that. I was there in April. And France, Germany, UK, Austria, and so on. It's pretty big. Can you hear me in the back? Okay, thank you. That's one. Second is we have 39 societies, 39, almost 40 societies. Power, control, magnetics, signal processing, computers, communications, many of those. Very diverse. 40% of our members are not electrical engineers, 40%. They're doctors, they're lawyers, there are MBA people, physicists, many of these. So we are very diverse. So when you say IEEE, it doesn't mean electrical engineers. We don't define anymore what is IEEE, just say IEEE, that's it. We have a staff of 1,500 to 1,500 in New York, New Jersey, manage this. Issue came up publications. We published 200 journals and magazines, 200, and a staff of 600 manage those. We talk about free open access, free to whom? It's a big question, free to whom? To the user or to the author? We have open access fee because we pay the cost of producing this paper and make it available to the user. Example, I belong to a Power and Energy Society. We have 6 journals. I was EIC of one of those 6. It costs the Power Energy Society for every 10-page paper, $600 US to produce the paper, produce, not write. Checking for clarity, checking references, HTML, and of course, plagiarism. Somebody's paid that money. So my answer is, if you make the open access green, nobody pays, either the author or the user. Is possible. Who pays the cost? One is called benevolent government or benevolent corporation. It's happening in China today. The Chinese, the power company, they pay for open access fee for papers that IEEE is hosting today. It's possible. We will think about what are the models. That's one question. Second is, we are an infrastructure provider. IEEE, we call, is not a technology provider We provide access to technology through our conferences, our publishing materials, and our education products. That's okay. So this is the issue, access to technology, not technology provider. So with that, let me stop here and come back with more questions later on. Thank you.
Very good. So the third question then is for Michel, and the whole process of transition from research to innovation, which Luc Cheffneux described so clearly within the European context, there's a general feeling that there are some blocking points, there are some difficulties and so on. How would you characterize the whole ecosystem? How do you think it should be working?
Well, first of all, despite the name, I mean, I'm the only Belgian guy of the four people here. Now, I did some innovation for years without knowing I was doing innovation. I was just working as an engineer. And actually, I became conscious of what it all was when I was Secretary General of ERMA, European Industrial Research Management Association, and started working on that. And we had a lot of contacts with the European Commission at that time. And the European Commission is a huge machine. It's more than 32,000 people. And it's 24 directorate generals, like budget, like agriculture, like competition, like R&D, and so on, and 24 service departments. Now, if all of those elements would be independent, that would already be complex, but they are not. And they interact, which makes it even more complex. So, for instance, you have the EIT, European Institute of Technology, which was created in 2008. And for some reasons, it was located in Hungary, Budapest. It didn't really deliver, according to the people at the Commission, what they expected it to deliver. And so in 2017, there were voices of members of European parliaments suggesting to modify it, to improve it, to so on. But what happened really is that in 2017, the European Commission created another entity called the European Innovation Council. Now, whereas the European Innovation and Technology Institute of Technology depended on the Directorate General Education, the other one depended on the Directorate General R&D, Research and Development, which already makes things more difficult. On top of it, because there were other members of European Parliament complaining about what was the need to make the system even more complex by adding a new structure, then in 2021, there was a memorandum of understanding signed between the two organizations, which is still in place. So this is an example of the complexity of the way the European Commission works. It's not a criticism, it's something you can notice. And the fact is that the European Innovation Council is further divided into 3 different categories, which I'll quote according to the terms of the Commission. There is the Pathfinder, which is support to research teams to research and develop or emerging breakthrough technology. The EIC Transition, which is actually, as they say, the Europe's flagship innovation program to identify, develop and scale up breakthrough technologies and game-changing innovations. And finally, the Pathfinder, which is support to research teams to research or develop an emerging breakthrough technology. So it's difficult to actually find out when you have a project and you want to build a consortium, who you have to address your request to. It's a difficult approach, and it takes time. It is in such a way that whereas big companies have special departments to manage that with people that are trained and efficient, for most SMEs, it's a difficult task to enter in a consortium project with the European Commission. And that's a thing that the Commission is well aware of and has tried to improve and is improving, because there are progresses, of course. But as I said, it's a big machine, and you don't move it, it moves like a big tanker. It takes time to change things. On top of it, There was in 2017 a result of a 2 years research program, which I was honored and pleased to participate in, called the ENIRI program. It was managed by a big lawyer consultant, which is Bird and Bird, and they were experts, some from the Commission, some from the universities, some from the industry. You know, we had about 20 meetings over 2 years, and there was a more than 1,000 pages report published, which basically states that they compared the research result and efficiency of the European area towards 9 other areas: Australia, Brazil, Canada, China, India, Japan, Russia, South Korea, and USA. And the conclusions were that all these areas, on average, had less, should I say, less disabilities to develop their research than we had in Europe because of a number of rules which are specific to the European Commission. I'll give you a few examples. One rule is the transparency requirement, which means that when you introduce a project, you have to describe it to some level of details. Now, for a big company, they get around it, but SMEs are kind of, reluctant to, because they're not sure of their intellectual property protection and so on. So they're kind of reluctant to disclose too much of what they want to research. So that's one issue. Another issue that we have at the European Commission also is the request for state aid. Now, as Luc outlined before, there is a time in the R&D towards innovation process where it starts becoming costly. And that's when you get to have, prototype in a more or less real environment, and you have to invest a lot. Around TRL, technology readiness level 6 to 7. Now, that's when the European Commission stops funding things because they say it might distort competition. One of the conclusions of the ENIRI report was it may be true in general business, but it's not applicable to R&D. Whereas DG competition comes in and says, stop, you can't put money in that project anymore. Which means that the number of projects which are potentially interesting just die in the Death Valley. And the files are put somewhere in a cabinet and are forgotten about. So it's not hopeless. There are a lot of progress being made, but it is slow compared to the pace with which other regions of the world are developing.
Thank you very much, Michel. And we have this situation in Europe, of course, with a wide variety. And a few minutes ago, we heard a talk where it was said, for instance, that the Flemish part of Belgium had many more RTOs, while the Wallonia was much weaker in this respect. So that's an interesting point that I've heard from Luc many times. Of course, Europe is very diverse. And I'd like to ask Anna, how in the last, say, 5 years or so, the research scenario and possibilities in Poland have evolved?
Well, I would say that they have improved due to also including the European funds that were given for the innovation. And especially within the last few years, there's been a lot of programs which promote the cooperation between the small and medium enterprises and universities. So I believe that within these programs founded by the National Center for Science, for Research and Development, a lot of innovation has been developed, but there are also some other initiatives taken to boost this cooperation between the universities and the academia. One of them referred to the institutional evaluation of the universities, and within this evaluation, the universities are awarded for the cooperation with the industry, and they benefit from any income that they include or they obtained from this kind of collaboration and cooperation. And also within the last few years, the implementation doctorate has been introduced. So this is a kind of framework for people from the industry who would like to pursue for the PhD degree, but not within the academia, but solving the specific technological problem for the given company. So this kind, at least at my university, I've been observing this, that this kind of framework has been getting an increased interest of the researchers from the industry. And also there are some tax incentives for the companies which do the research and development, and they can benefit from this kind of activity. And according to the information which is given on this issue, this kind of incentives works, and more companies within Poland are interested in performing the research and development. So I think that these are the most important issues to be raised within this subject.
Very much, Anna. And actually, you know, the IEEE Saifur, President Saifu Rahman, recently mentioned just a few minutes ago, he mentioned the issues of cost, you know, huge costs associated with open science, which were not mentioned elsewhere in this meeting. It doesn't come without costs. You need data centers, you need staff to prepare and upload documents, because once you take the responsibility of uploading them, they have to be in some sense perfect, and so on. The issues also of plagiarism, of course. This is a big problem that we have in the scientific community. I'm often surprised to see even the diagrams that I have published in a journal reappear in some other journal, exactly the same diagram with exactly the same caption. So there are very interesting things going on, not that I mind, but you know, it's kind of funny to see the things being reproduced. So on the other hand, we as engineers and producers of research papers and so on, we sometimes think of the IEEE and even as members as being an organization that to a certain extent exists without us. So they take our work and then they carry on with it. And I'd like to ask Saifur about, you know, the tensions, because he's very aware of this as president, the tensions within the organization between the core organization and the membership.
Thank you, Errol. Thank you very much. Two answers, or two parts of this question's answer. One is, let me go back a little bit. What is IEEE doing today for open access? We support three things. One is called Code Ocean. Code Ocean. Somebody said this morning, in order for us to have our result reproducible, the other party has to have access to my code. Question was, where do I put my code? So you can test it to make it reproducible. Code Ocean does that. So library can put your code at no cost to you, and then you can tell people in your paper, this code available with the DOI from this place. Done. Code is shared. Second is data port, IEEE product, data port, where we encourage authors to put the data for their research in that repository so that a third party can use the data to test my algorithm. It's being done today, very useful. And third is Take Archive. We have an archive free to publish your unreviewed paper content. Get some input. I like that because I wrote a paper. I want to see how people think about it. They may have some questions. Based on that, I can make the paper better. That's available today. Many of you do not know that. Code Ocean, Data Port, and Take Archive. Finally, issue here just mentioned, open access publications. IEEE has 26 journals open access, meaning you as an author, once it is accepted, have to pay some fee so the rest of the world can see it for free. The question is, people have this feeling called pay to publish. If you're paying $1,000, it's published more easily. It's not true. Because when you get that paper submitted, we don't ask for money at that time. Review this as if it is closed paper. Our reviewers do not know it may be open access later on. Don't know that. So when the paper is accepted, we send a letter to the author. Do you want it closed or open? At that point, they make a commitment. That means review, that's the tension you mentioned. Reviewed as if it is a closed paper. Quality is the same. So that's the way we manage this thing. Other tension is people in developing countries cannot pay the $1,000. You can pay from Belgium, a guy from India cannot. So if we have a request from an author in India or whatever that we cannot pay, we ask, how much can you pay? $100, okay. We will pay the $900 ourselves. That's happening. So we are not as stiff as some might think. We're not a business. We're providing access to technology to the end user. So I hope that makes some sense. Maybe over lunch or later on, we can take more time to explain this. Thank you, Errol.
Thank you very much, Saifur. So this was extremely interesting as a way of operating. I'll add there are other tensions, but I will not go into them right away. We will talk about them over lunch. But then there's yet another question about open access, open software, open innovation, etc., which is intellectual property rights. Because, you know, as soon as, if you publish an algorithm, that's one step. And if you have not patented it, you have no protection. If you put your software also online, that doesn't stop anyone from going forward and then using it in a product. And then, of course, the authors don't necessarily get something as a counterpart. And I was wondering whether Michel would like to comment on this whole thing of openness and intellectual property and legitimate rights of authorship and so on.
Well, as a matter of fact, you know, industries try to protect their intellectual property because that's how they make their business up to a point. As it was said by Mr. Logan before, you know, the appropriate way, or I don't recall the exact terms of it, you know, it has sometimes to be protected up to a certain level. But, you know, I'd say the European Commission has another approach to it. I mean, in the sense that they want, first of all, to have a lot of information if you introduce a project. And then, as I said, also, you have people you don't basically know very much. So the transaction costs, as Ronald Coase, which was a Nobel Prize in economics, said, is very high. I mean, there is no specific trust. Everything has to be agreed upon, contract signs, verified in various ways and so on, which means it takes a lot of time to achieve anything. And that's probably one of the reasons why some projects never get to their end. On the other hand, to finish this panel with a kind of an optimistic sign, there are some issues, there are some activities which have developed, and namely, there are 6, it probably will be mentioned this afternoon by Leopold, but there are 6 big research organization, European research organization, which teamed up under the CERN authority. And they came to the conclusion that they have developed, and they are developing a number of tools and devices for their own use. And that some of them could be used, enhanced, modified for other fields of activity, like medicine or material science or whatever. And they came up out of that, with the support of the European Commission, came out the Attract project, which was basically, it's not a huge amount of money, but the concept is interesting. They kind of saved 20 million euros for 170 projects, which were carefully selected among a number of applicants. And after a year, they decided to, we are now in Attract number 2, they decided to take the project which was the most promising to develop them further. Now, this is an interesting approach because it gets things from the field versus having something that you have to push through the European system. Is it the beginning of something bigger? Maybe. Is it the one sales action? We don't know. But certainly it's an interesting approach. I think what we need is really what Victor Wang, a venture capitalist in California, called a rainforest model. That is, you know, things happen between people knowing each other, venture capitalists meeting people in universities, RTOs and so on, having this network of contacts, trusting one another, and hence advancing much faster than with the red tape and the bureaucracy.
I think with these wise words, we're very close to our conclusion. I'd just like to add one more thing, money. So broadly speaking, we think we have a lot of availability of funds across Europe. However, the prime operators of the research world and also of the development work, universities, engineering schools, technological universities, and so on, and business schools, across Europe are, in my opinion, underfunded. Very few of them have any endowment. Endowment being what allows them to take initiatives which aren't prepaid. So that aspect is very weak across Europe. The second thing is that overheads in general are very low. We had a presentation, for instance, about ANRT, which relies a lot on the Grande École and universities and only pays or only encourages the payment of the students themselves or the PhD students rather than the actual costs of the schools and universities to run projects and so on. And generally, we are also underfunded and under-supported in the area of PhD students. While, you know, in one of the 100 best American universities, you will find 100 or 150 or 200 universities, you will find typically 10 PhD students per faculty member in the technical areas, in the sciences and so on. In Europe, we're more running around 1 or 2. So we really have to go a long way towards a better base support of research across Europe. Thank you very much.
Some time for questions from the audience. Maybe Errol, you would like to.
Absolutely. So we will take questions, of course, and then we will pass them on to members of the panel.
Jan has a microphone. So the audience, don't want to keep the audience silent all the time.
Yes, Errol, I would like to, Patrick Maestro from Eurocase. I would like to comment on the, as an industrialist, about this point of overheads. Yes, we need to put them at the right level. But if you input too much overheads to industries when they sponsor a PhD, then they will not come. So it's really a point of attention. Maybe they are too low, but if you increase them too much, you will have even more difficulties to get fundings for PhDs. And of course, as it was explained by the presentation by Clarisse, we are ready to fund PhDs because the interest of that for industry is key. So it's really a specific point to discuss and to find the right numbers, because sometimes I see overheads that the people want to charge me and I say, no.
It's what you say is very interesting. And of course, it's a matter of cost. At the end of the day, it's a matter of cost. On the other hand, I'll just say two things. One is that overheads in the US, when they are low, they are 45%. And a lot of European companies go and fund PhDs in American universities. Okay, so that's the first point. The second point is one important reform that was done by the Blair government in the UK was to recognize the real economic costs in universities. This was a very important point because until then it was like the freebie. You come along and it doesn't cost anything and ask the professor to do the work and the student to do this, and all of that is fine. But the reality is that as soon as a university starts doing anything, they will have to find the time of the professor. They will have to pay for that. They will have to find the space to do it. They will have to heat and cool and get the electricity and get the equipment in the laboratory. So in the days when European universities were amply funded, all of this was never land, and it was wonderful. But things have changed considerably since the 1920s, when there are very few universities with luxurious facilities. Today, we are in a real situation where universities have to count their pennies. So I think we all have to, yes, we shouldn't be too expensive, but we shouldn't be cheap either, because if you're cheap, the quality is bad. There is no magic. So we have to be realistic about all this. Yeah, absolutely.
Can I add one more thing to what he said? Like, how much is enough? Okay. Very good question. At Virginia Tech, where I teach, we pay every student who are funded from teaching or research $30K per year, plus tuition fee. So they can survive. But if you bring in an MS person, 27-year-old, he or she may be already married. What do you do? Wife, husband can support the other part? Always not. We have a program, we go to industry, give us 60K, not 30K. Industry money special. For this PhD person to get 5K per month, decent salary, survive. Then he or she is not concerned about paying rent, it's done. Then the industry has some input to his or her project definition. Most likely, he'll be employed, she'll be employed by the industry once they graduate. That's taking shape, but not widely known in the US. But the good, how much is enough? 60K per year is not bad. 30K, I was 20K when I was a student. It's just possible, but ideas are flourishing now. That's my point. It's possible. Thank you.
My name is Walter Leijten from KU Leuven. One element that has not been mentioned, which I think is critical though for innovation, is risk-taking. And that is an enormous difference between the two sides of the ocean. In Europe, we are focused on reducing risk as much as possible. It starts already at the PhD level. Our PhDs have to finish in 4 years. They have to have a project that's certain to give results because they have to publish at least one paper, and on and on and on. Then the universities, when they submit a research proposal, it's judged by feasibility. If there's any risk in it, it goes to the bottom of the queue. Then there is the VCs. The VCs are focused on how to reduce as much as possible the risk of their investment. There's no one who is willing to go like in the United States. I like this guy, I like his ideas. I'm going to put in, $500,000 so that he can pursue his idea and show it works or it doesn't. Then there is the governments. I could go on and on and on. So if industry is usually, established industries, very averse to taking the risk, for instance, of using a new piece of software, because what you get is the question, who is going to maintain this software? Are you still going to be there in 10 years? We have obligations towards the government that our data are verifiable, that the software is going to still be there in 10 years when they want to check it. So this really is an enormous headwind for innovation. I was wondering, what are you going to do about it?
Michel, perhaps you could.
That's a definite issue. Absolutely. I agree with you 100%. I have no quick fix, otherwise I would have already proposed it. But for sure, people are very reluctant to take any type of risk here, and with some exceptions, but not many. And I think it's a characteristic of the European society. We see it also in the how would I say, when you have an association of alumni and so on. I remember I was in charge sometimes of trying to do some fundraising from Brussels University, and I was in contact with Cambridge University and the Anglo-Saxon world, and they said, well, this is our 800th year, we're going to collect 800 million pounds. Turns out they collected a billion pounds. For us in Brussels, this was unbelievable. But the old boys network, the idea of taking some risk, knowing that you can lose, and so on. This is definitely something that you have in the States and probably in some other parts of the world. But in Europe, it's very difficult. And this is a state of mind, and states of mind are probably the most difficult things to change. So I don't have a quick fix, but I agree with you 100%.
maybe it's not a state of mind, it's a law. So you know that Europe is looking at changing in the US, you can go bankrupt many times over your life. If you fail, that's okay. You will still be able to do credit. You can still buy a house. You can still buy a TV on credit. You can have multiple credit cards. So you will still find ways to have investments. Big investors in the US have failed many times, right? In Europe, it's not possible. If you are bankrupt one time, it's for life. You will never have credit ever again. You can't buy a house. You can't buy the university for your kids. You can't. I don't think it's people. I think it's the law. So actually, Brussels is looking at changing the bankruptcy law. So there is a proposal coming. So you guys should all look at national level that this one is supported as a change. I think that's the key one.
Might be the chicken and egg problem. I don't know who is responsible, but certainly this is another aspect, yeah. Sure.
I know they will speak. They have a microphone.
Some 25 years ago, Eurocase produced a report on venture capital. And one of the things we discovered at that time was that there were huge differences between the different countries of Europe and the whole attitude of the links between universities and industry. In some countries, it was positively determined to be against it, that academics could not work in conjunction with industry. In other countries, the other situation applied and there was close cooperation. I wonder if anything has changed in the last 25 years in this regard.
Well, I'm not sure that there's been so much change, to tell the truth. I think this is a slow process. Now, there may be some responsibility with the legal system, as Muriel outlined, but I haven't seen many changes in the last 35 years. And I've been around the last 35 years.
Well, perhaps some things have changed. I see this from a very personal perspective. My son is a venture capitalist. And he's based in Porto. His company is based there now. It used to be in London, but after Brexit, they moved to Porto. And he has been developing several funds, one after the other, where they actually invest, of course, in companies, not just in Europe, but they invest worldwide. Some of them in the US, some of them might be in Israel, some of them might be in Germany and so on. And he's also been involved in it. So I think that there is much more of an effort in this direction. And a lot of young people now are going for small companies rather than big organizations. They're going for small companies for their own startups and so on. So I think there's been an evolution. However, the general risk averseness of various enterprises is definitely, part of our culture. And certainly in the scientific milieu, I see people, I know my own students who have gone into science careers in France, typically, or elsewhere. They have basically stuck to one organization. They have managed to enter INRIA or managed to enter CNRS or whatever, and they've never imagined that they could change. And they've just used the facilities of these organizations to build their careers. And I've often criticized them for that. I mean, they've not even competed for a position at a different organization. They've tried to optimize locally. And I think this is probably one of our cultural traits in Europe. We're not able to say, well, I've done 5 years of this and now I should do something else. And that's how it's been going on. I mean, I'm a counterexample of that, of course. I've changed institutions so many times. I think 5 years is when you actually can do something, and 10 years is getting to be too much.
Let me add one quick thing to what you just said. I'm looking from US looking out. We get Chinese investors coming to Silicon Valley to invest because they don't take a risk. So risk-taking is a two-way traffic, not just the investors' ideas, also the parent company where investment is made. They have to understand that they have some obligation not to do greenwashing and the sky is the limit. So this is the balance. It is a cultural thing that takes time. So 25 years ago, it started. So maybe US started 50 years ago, more than that maybe. So if you look at The cultural shift takes time, but I have many friends in many European countries. I see them in conferences. I see even among the professors, some change in thinking. It's not professor for life. You have, in our case, my students, I have to find money for funding them. There's no money from the state, zero money from the state. I must have projects who will fund their PhD research. That's not the case here. So yes, it brings uncertainty, but it makes me on my toe all the time. So a full professor in the same size office as a young assistant professor in the US, same office size, 15 square meter, standard size, no big deal. Similarly, an assistant professor is easier to get money because he or she is new, and for me more difficult because I'm more competition oriented. So point is, you have to make it so that nobody takes things for granted. You have to earn your living as you go. So that's the difference, I think.
I was a department head at Duke University. One of my colleagues, who is Indian, of Indian origin, of course, he's a US citizen, used to tell me a professor is a licensed beggar. So you're there just to go around and try to raise money, essentially, and you just have a license to it.
One thing that has changed, and which is also an indication of the lack of risk-taking attitude, is the crowdfunding, which actually has seen development in the last years. Unfortunately, crowdfunding are not in the same league as big projects. But it's something that appeared to try to compensate probably the lack of money invested in a number of ventures.
Okay.